Now let's a little bit talk about the system software in its interaction with the hardware system. This is just for revisit our conception, or at least get some conception if you are not already taken like an operating system class or compiler classes and stuff like that. Uh, Basically, what we do as a programmer as is write a high level program like C, C++, Java or whatever, right? So we write some high level program in the high level language, we write some program in a high level language, and there is a compiler system which breaks down this high level program into assembly code. Okay, and then there is this system tool assembler which generate machine code with the relative address from the assembly code. Okay, so this one too, compiler, assembler, there's the system software. And of course we have this operating system and loader associated to start executing the program. So as till assembler level, you machine code is ready with some relative address, means like we don't know where this program is going to be loaded in the memory, so every memory reference is kind of relative to the start of the program. Okay, now operating system, when you type in or double click some execution on the operating system or type in some program name .exe or something, what operating system will do, it will find a suitable address and free address so that program can be loaded in the memory, and it gives, this is, let's say that is a start address, it pass it over to another system program called loader. Okay, we are not talking about the linker right here, there is an intermediate step also of the linking from the machine code and stuff like that, but main point is that how this program get executed, right? So it gives a start address to the loader. So loader, these utilities or system tool sole purpose is to retarget the addresses of this machine code. Okay, so it was a relative address, it knows now the start address, so it replaces all the relative addresses with the absolute address with the known address, like respect to a known start address. So machine code transform that and also write into that memory location. Okay, machine code with the absolute address loaded at this start address. So once it is done, then operating system simply change program counter to the start address so that your processor can fetch the next instruction as the very first instruction of your program that you have written. So that's how your program is kicked off and start executing. Okay, so what that view become, like you write a program, compile it, compiler generates the assembly code, then it goes through the assembler, it generates the machine code with a relative address, then when you start that program, operating system find out some space in the memory with us and give the starting address of the space to the loader. Loader translate the machine code with the relative address into the machine code with the absolute address and load into that memory space starting from the start address. And once it is done, your operating system change program counter, add program counter value to the start address, and your processor fetch your first instruction of the program as the next instruction, and that's how the system works. So I think that's all for our lecture today. Please let me know if you have any question, query, and I'll send me email or ask in class, so that I will just I can send you response over email or explain to all these things in the class.